let's start the notes on 14.2, Algebra Techniques for Finding Limits. So just continuing our lesson on limits, but now doing the algebraic way. The first new thing is how we have the limit as x approaches 3 of 5. This 5 is like the equation y equals 5, which looks like this, like up 5 and then a line. So at any x value here, our y value is always 5. So whenever you have a limit with two constants, it's always what the line equation is. So the limit of this one is 5. This equation is the graph y equals x, which is a linear line. And at any x value, your y value is the same. So the limit as x approaches 3 of x is 3. Again, here we have a constant and a constant, so the answer is negative 8. And here we have the linear x as we approach negative 1/2, so our answer is negative 1/2. The next piece is just saying that you can distribute the limit when you're adding. So we could do the limit as x approaches negative 3 of x plus the limit as x approaches negative 3 of 4. The limit as x approaches negative 3 of x is negative 3, and the limit as x approaches negative 3 of 4 is 4. Yeah, okay. So negative 3 plus 4 is 1. I was skipping steps. And then you can do the same thing with subtraction. So the limit as x approaches 4 of 6 minus the limit as x approaches 4 of x. The limit as x approaches 4 of 6 is 6, minus the limit as x approaches 4 of x is 4. 6 minus 4 is 2. We can also do this with multiplication. So the limit as x approaches negative 5 of negative 4 times the limit as x approaches negative 5 of x. So the first one is negative 4, and the second limit is negative 5. Negative 4 times negative 5 is 20. So besides doing that, we can also just plug our x value into the equation. So 3 times negative 2 minus 5, which is negative 6 minus 5, which equals negative 11. Again, plug in 2 for x in the equation. 2 squared is 4. And 5 times 4 is 20. Keep going. We're going to use this same method of plugging in. So negative 4 times 2 cubed. 2 cubed is 8. And negative 4 times 8 is negative 32. Plug in 2 for every x. So 5, 2 to the 4th, minus 6, 2 cubed, plus 3, 2 squared plus 4 times 2 minus 2. 5 times 2 to the 4th is 80. 6 times 2 to the 3rd is 48. 3 times 2 to the 2nd is 12. 4 times 2 is 8. And then minus 2. And together that equals 50. Again, we're going to go ahead and plug in. So 3 times 1 minus 5 to the 4th power. 3 minus 5 is negative 2, and negative 2 to the 4th power is 16. The square root of 5 times 0 squared plus 8 equals the square root of 0 plus 8, which equals the square root of 8, which simplified is 2 root 2. The last one, 5 times negative 1 cubed minus negative 1 plus 3 to the 4/3 power. That's negative 5 plus 1 plus 3 to the 4/3. Negative 5 plus 1 is negative 4, and negative 4 plus 3 is negative 1, and negative 1 to the 4/3 is negative 1. Again, we always want to start by trying to plug in that x value. So let's do that. 1⁵ is just 1, so that's 5 minus 1 plus 2 over 3 plus 4. And 5 minus 1 is 4, 4 plus 2 is 6, and on the bottom 4 plus 3 is 7. Again, start by trying to plug in first. However, if we did plug in first here, on the bottom, we would end up getting 0, which is undefined. So what you want to try and do first is simplify the fraction. And we can factor the top by what multiplies to -6 that adds to -1. That would be -3 and 2. And the bottom is a difference of two squares, which is factored as x minus 3, x plus 3. And then we'll put our factors on the top. And now you can see that we can simplify this fraction by canceling out those x minus 3's. And we're left with the limit as x approaches 3 of x plus 2 over x plus 3. Now when we plug in 3, we get 3 plus 2 over 3 plus 3, which equals 5/6. All right. If we plug in 0 here, we're going to get that 0 on the bottom. And we can't simplify this anyway. So our next step is splitting up this fraction to 5x over x minus sine x over x. The left fraction, the x's cancel, and we're just left with 5. And we can do like what we learned up above, where we split the limit to the subtraction. So the limit as x approaches 0 of 5 minus the limit as x approaches 0 of sine x over x. The limit as x approaches 0 of 5 is 5. And remember, this is our identity limit that we learned about in our last video, that it equals 1. And 5 minus 1 is 4. This one is a little tricky to see how to start this one, but we're going to factor by grouping the top and the bottom. So the first set of parentheses on the top have two x's in it, so an x squared, and we're left with x minus 2. The second parentheses, both numbers can be divided by 4, and we're left with x minus 2. So that means our factors are x squared plus 4, x minus 2 for the top. So let's go ahead and bring that over to the left. The bottom, the first set of parentheses, both have 3 x's, and you're left with x minus 2. And the second parentheses, look, they don't have anything in common, but they can both be divided by 1. So the bottom factors are x cubed plus 1, x minus 2. You can see our x minus 2's cancel, and now we have the limit as x approaches 2 of x squared plus 4 over x cubed plus 1. What I'm going to do is plug 2 in. So 2 squared plus 4 over 2 cubed plus 1. And that equals 4 plus 4. 2 cubed is 8. And that simplifies to 8 over 9. The one thing I didn't do first for this problem was plug in 2 at the very, very beginning. But I already knew it wasn't going to work for us. But again, you still want to always try and plug in that number first to save you some work of having to simplify if you don't have to. But otherwise, let me know if you have any questions.